Hello again, and it's Level 3 Cambridge Technical and Engineering. It's a revision session for Unit 3 Principles of Mechanical Engineering. And we're going to look at the mock exam paper in this video. We're looking at question 3 and we're looking at part B. And we're going to be looking at bending moments. Now this is a particularly tricky part of the course. And students do really struggle with this, so I'm going to try and take this really slow and work it out step by step, but I don't want to go into too much detail. I'm just going to give you the technique for processing this sort of question so that you can start to move towards an answer. So let's have a look at the question. We've got a diagram, figure 5, showing a simply supported beam, and there are loads of 14 kilonewtons, 16 kilonewtons, and it's supported at points B and points D with 25 kilonewtons and 5 kilonewtons. The reaction forces at B and D have been calculated for you. The reaction at B is 25 kilonewtons in an upwards direction, and at D is 5 kilonewtons in an upwards direction. It says draw a labelled bending moment diagram for this beam. Now then, to make things simpler for yourself, although the diagram isn't perfectly to scale, it's sort of roughly estimatable. So it's 4 metres, 6 metres and 2 metres, so it's a total of 12 metres. So what I've done down here is I've looked at that scale and I've said to myself, well, there I've got 6 centimetres, so I'm going to give myself 1 centimetre. 10 millimetres is going to give me 2 metres. So I can now mark on here, roughly to scale. So that's going to be 5, so that'll be 10 metres. 4 plus 6 is 10. Gives me point C, and this one's going to give me point D. And that's helping me out. Now, again, down the side here, make life easy for myself, we've got a maximum calculation, you'll see in a minute, of 56. So you might have to do your first calculation and then give yourself a scale. So we're going to go 10, 20, 30, 40, 50, 60. 10, 20, 30, 40, 50, 60. So do your first calculation and then you can set up a scale for your graph, and it just makes positioning things a little bit easier for drawing your bending moment diagram. Right. How to do this then? If we remember, this is a bending moment, and a moment equals force times distance. What we're going to do is we're going to start at one side of the beam and work our way across, considering each point as we go along. So let's start with point A, which is going to be in here. Now at point A you have 14 kilonewtons, but you have 0 distance. So effectively you've got 14 kilonewtons multiplied by 0 equals 0. So there is no bending moment at point A. So the next step is to go to B. At B we have 14 kilonewtons. So we're just working on the left hand side of the drawing as we go across. We're working in this direction and we're considering everything on the left hand side. 14 kilonewtons at 4 millimeters. So we could have 14 kilonewtons times 4 meters, and that's going to give us, now it's a downward force, so I'm going to use a negative to indicate downward force, so that's going to give me negative 56. So if I look at my graph, 10, 20, 30, 40, 50, 55, I'll label that minus 56, like so. push that up a little bit so you can see it. And I've got my first calculation. And again, like I said, if you do your first calculation and you get a value, you can then sort of calculate your scale for your graph. So at minus 56, and so the bending moment, that part of the beam would look like that. Okay, so we've done point B and we've calculated everything to the left. So we now move to point C and we calculate everything to the left of point C. We don't look at point C itself, we don't look at the 16 kilonewtons, we're just looking at the forces here and the forces here. So at point C here we've got, well, let's have a look, we've got 14 kilonewtons, but we've got that force times distance, so 14 kilonewtons times 10 meters. 14 times 10 is going to equal 140 plus, now remember that's a negative, so minus 140 plus we've also got 25 kilonewtons over 6 meters. Okay, so that is going to look like $150. So we've got minus 140 plus 150, so the result is going to be 10, which is going to be there. So at point C we have positive 10. Okay. Now at point D, so if we go to this point here, we're going to have minus 14. Let's go back to our diagram again so we can see it. So we've got minus 14 here, multiplied by 4, 6 and 2, so that's going to be by 12. So we're going to start off with minus 14 times the 12 plus, now we've got 25, but now it's over 6, 7, 8, so that's 8 meters there, plus we've also got another downward force, so we take away the 16 over the 2 meters. And if we check that on the calculator, we will see, so we'll bring it across there so we can see our, so we have negative 14 times 12 plus our 25 times 8 minus our 16 times 2. So the resolved forces at D will be 0. And if you remember what I said before, you're wondering what about the 5 kilonewtons, but like I said, at each point we only consider what's happening to the left. So at point B we look at the 14 kilonewtons, at point C we look at the 14 and the 25, and at point D we're only looking at 14, 25 and the 16 kilonewtons. And that is what your diagram would look like. I hope that's been useful. It's a little bit tricky, but it is worth watching the video a couple of times and perhaps having a practice and draw out a diagram and see if you can follow the calculations. So 14 times 0, 0. 14 times 4 meters, minus 56. At point C we've got minus 14 times 10, 25 times the 6, and at point D we've got minus 14 times the full 12, 25 times the 8, and minus 16 times the 2. And we plot those on our graph to give us our bending moment diagram for the beam. I hope that's helped, and do well in the exam.